Our next example in the products of powers of sines and cosines. I have sine to the fifth, cosine squared dx. Now, so what's our rule of thumb? Whichever one is odd, peel off one of those functions and then convert everything else to the other function. Or what's not so much the other function, convert this into what's going to create that differential. So sine is odd. I'm going to peel off one of these factors of sine. Well, that's reserved. Nobody else gets to touch that because that's reserved for the differential. What we have left is sine to the fourth cosine squared. Everything's multiplied, so it's okay. Now, if sine is the differential, that means all the other functions have to get converted into whatever function creates sine as the differential. What function creates or can be expressed in terms of sine as the differential? Cosine. Is it clear? Cosine creates the expression of sine. So we need to convert everything else to cosine. If you reserve sine, convert to cosine. If you reserve cosine, change to sine. Because their derivatives are almost mirror images of each other, except for the negative sign, this is pretty straightforward. Everything converts to sine. So now we have to convert to cosine. Notice, this was odd. We take one away. This is always going to be even. If this is odd, you take one away. This is always going to be even. If it's even, then we can use our Pythagoras identity. I can write this. Remember, sine to the fourth, think of that as being sine squared squared. Fourth power means squared squared. And I know what sine squared is. Sine squared is 1 minus cosine squared of x, but that's getting squared. Now, let me do that in 2 steps. I want to make sure that's clear. In 2 steps, this is sine squared of x squared, cosine squared of x, sine of x dx. That's reserved. That's the integral. But forget this too. This is sine squared. This is 1 minus cosine squared by Pythagoras. But that's been squared. Now you could do it here, but I want to clean this up a little bit. Square this out. Sorry, square this out. This is not just the first one squared and the last one. You have to FOIL this thing. You have to square that thing. So FOIL this out. If you do, that becomes 1. When you FOIL, you get minus 2 cosine x, and then the 2 cosine squared of x. And then you square the last. And then that's times cosine squared. I'm going to write out space. And then that's times sine of x dx. I ran out of space there. But see, 1 minus cosine squared, you have to FOIL that and get the cross product term. Now, distribute the cosine squared. And so at long last, we're going to get cosine squared of x minus 2 squared. When you multiply the bases, add the exponents. When you multiply the bases, add the exponents. And then we're times sine of x dx. And at long last, now we have sine reserved. Everything else is in terms of the other function. This is now Calc 1. That is the new part of our work. Getting from here to this place where you can hand this off to the Calculus 1 part of your brain. The rest of this is easy money. It's getting to here that's the issue, and all this is trigonometry and algebra. The good news is all this is trigonometry and algebra. The bad news is all this is trigonometry and algebra. So you reserve one off, that's squared squared. Sine squared becomes 1 minus cosine squared. You need to FOIL this to get that all three terms. And then the rest of this is straight, distribute in. The rest of this is straightforward. Derivative of cosine is negative sine. I don't want negative, so I'll put the negative out here. And the substitution is exact. And so what do we have? So what do we have out of that? We have that's equal to, by the substitution, cosine squared is u squared minus 2 cosine to the fourth is u to the fourth plus cosine to the sixth is u to the sixth. Make my bracket the same. And then sine x dx is negative du. This is negative. And so the antiderivative is, this is plain old garden variety power rule. U to the third over 3 minus 2u to the fifth over 5 plus u to the seventh over 7. And then back substitute to let u equal cosine, and we're out. So that's negative, and this is negative of this entire quantity, I should say. This is negative of the entire quantity. We can distribute that in if you like. How about if I distribute this negative sign in on the fly? So this is negative cosine cubed of x over 3. This is positive 2 cosine to the fifth over 5. And this is now negative cosine to the seventh over 7, and the constant, and we're out. All right? That is all Calc 1. Getting to here is the key notion. Getting to here. This is not brutally difficult, but you're going to learn some trigonometry, and you're going to solidify some of your algebra too. So this should be pretty straightforward. And anytime we have products of sines and cosines, if at least one of them is odd, if both of them are odd, if this is sine to the fifth, this is cosine to the third, then I would pick on the big guy. Wait, do we pick on the little guy? I think the smaller guy gives less algebra to work on. So pick on the smaller of the two. But that's the process if we have products of powers of sines and cosines, and at least one of the exponents is odd.